In episode 22, titled 2.2, Detect Missing Values and Null Patterns Before Analysis Goes Wrong, missingness is treated as a first-class data quality problem rather than a minor cleanup step. Missing values often change conclusions silently because the analysis still produces neat-looking numbers, even while the underlying sample has shifted. A metric can drift simply because a segment stopped reporting, a device stopped sending a field, or a collection process began skipping a question, and none of that is obvious if the result is only a single average. The practical risk is that missingness can look like a business trend, a security signal, or a product issue when it is really a measurement gap, and that confusion can survive all the way into decisions and reports. Missingness becomes easier to manage once missing, null, blank, and zero are treated as distinct states with different meanings. A null, often represented in databases and structured query language, or SQL, as NULL, usually means the value is unknown or not recorded, which is very different from a valid value that happens to be empty-looking. A blank string can mean a system stored an empty text value instead of a true null, which often happens when form fields are optional or when ingestion pipelines coerce types. A zero is a real numeric value with semantic weight, and conflating zero with missing can flip interpretations, such as turning no incidents into unknown incident count, or turning zero revenue into revenue not captured. Clear definitions up front prevent later steps from mixing states that should never be mixed. Patterns of missingness are often the first clue that something is wrong, because missing values rarely distribute evenly across a dataset. One common pattern is missing by time, where a field is complete for months and then suddenly drops out after a release, a vendor change, or a collection rule update. Another pattern is missing by region, where a data source is strong in one geography but inconsistent in another due to different systems, privacy rules, or operational processes. Device-driven gaps are also common, where mobile clients omit fields that desktop clients include, or certain operating systems encode values differently and create apparent missingness after parsing. Seeing missingness as a map across time, place, and platform keeps the problem grounded in real causes rather than treating it as random noise. A key analytical judgment is deciding whether missingness looks random or systematic, because that choice drives how trustworthy the remaining data is. Random-looking missingness can still hurt precision, but it is less likely to warp comparisons between groups if the gaps do not favor one segment over another. Systematic missingness means the gaps correlate with a characteristic, such as higher-value customers, a specific marketing channel, a particular device, or a certain time window, which turns missingness into a bias mechanism. When systematic gaps exist, the observed data is no longer a neutral sample of the underlying population, and simple summaries can become misleading even if they are computed correctly. This is why missingness is not merely a formatting issue, because it can act like a hidden filter applied after the fact. Fast quantification helps keep missingness from becoming a vague concern, and counts and percentages are usually the quickest way to make the problem visible. A field with 1% missing may be acceptable in some contexts, while a field with 20% missing often requires a deliberate plan, and the exact threshold depends on the decision the analysis supports. Counts matter because percentages can hide scale, such as a small subgroup where a few missing records represent a large percentage, or a large dataset where a small percentage still represents thousands of rows. Quantifying missingness by key slices, like time, region, channel, or device, turns a single overall percentage into a diagnostic picture that supports root cause thinking. Once missingness is expressed numerically, it becomes possible to track it over time as a quality signal rather than a one-time observation. Related fields often reveal dependent gaps where one missing value predicts another because the fields are collected together or derived from the same upstream event. A missing postal code might align with a missing region code because the region is derived from the postal code, so the real gap is in the postal code capture. A missing customer identifier might cause downstream attributes like customer tier or lifetime value to be missing, not because those attributes were absent, but because the join key disappeared. Dependent gaps can also show up in event data, where an event timestamp exists but the device type is missing, suggesting partial telemetry rather than a completely absent record. Looking across related columns keeps the analysis from treating each missing cell as an isolated accident, because many missing values travel as a group. One of the most common failure modes is dropping rows blindly, especially when missingness clusters in meaningful segments. Removing incomplete rows can feel tidy, but it quietly changes who remains in the dataset, and the remaining sample may no longer represent the original population. If missingness concentrates among certain regions, devices, or customer cohorts, dropping rows amplifies that bias by removing those groups altogether. Even when missingness is evenly distributed, dropping rows can reduce sample size enough to make results unstable, particularly for rare events or small subgroups. The more responsible approach begins with understanding what the missingness is signaling about collection, joins, or transformations, because that context determines whether rows should be excluded, repaired, or flagged. Treatments for missingness should be chosen thoughtfully because each treatment makes an assumption, and assumptions need to match reality. Imputation means filling in missing values using a rule, such as a typical value, a model-based estimate, or a value carried forward in time, and that can be useful when the missingness is limited and the field behaves predictably. Flagging means creating an explicit indicator that a value was missing, which preserves the fact of missingness and can be critical when missingness itself carries meaning, such as address not provided versus address unknown. Exclusion can be appropriate when the missing data makes a record unusable for a specific question, but exclusion should be tightly scoped to the analysis rather than becoming the default for the entire dataset. Each treatment should be evaluated in terms of how it affects comparability across groups, how it changes distributions, and how it might influence downstream decisions. A sign-up funnel example makes these patterns concrete because funnels often contain missingness that looks like behavior but is actually instrumentation loss. Consider a funnel with steps like landing page view, account creation, email verification, and first login, where each step is recorded as an event with shared identifiers. If the device field is missing mostly on the email verification step, it may not mean users changed devices, but rather that the verification step occurs in a context that does not send device metadata reliably. If the region field becomes missing after an update, the apparent shift in conversion by region might be a data artifact rather than a market change. If customer identifiers are missing at the first step, later steps may appear to drop off because the linking key is absent, not because users abandoned the process. The funnel still produces a clean conversion rate, but without missingness profiling, it can tell a story that never happened.
Decisions about missingness need to be documented so results remain defensible later, especially when stakeholders ask why numbers changed across versions of a report.
Documentation should capture the definitions used for missing, null, blank, and zero, because those definitions often drive reconciliation disagreements between teams.
It should also capture what treatment was applied, what the rationale was, and what trade-offs were accepted, such as slightly more bias in exchange for a usable dataset, or slightly less completeness in exchange for higher confidence. When imputation is used, the method and scope matter, because filling values in one subgroup but not another can introduce subtle distortions. Clear documentation turns missingness handling into an explicit part of the analytical chain, which makes both audits and future maintenance far easier.
Missingness should be rechecked after merges and transformations because those steps can create new gaps even when the original sources were complete. A merge can introduce nulls when keys do not match, when the join logic unintentionally filters records, or when data types differ in ways that prevent matching. Transformations can create missingness when parsing fails, when derived fields depend on inputs that sometimes disappear, or when business rules treat unexpected values as invalid and set them to null. Even something as simple as trimming whitespace can change whether a field is considered blank versus present, which affects later logic. Rechecking after each major pipeline step helps isolate where the missingness was introduced, which is often the difference between a quick fix and weeks of confusion. Hidden nulls often come from parsing and type conversions because ingestion systems frequently substitute placeholder values that look valid but behave like missingness later. A date field might contain a default like the 1st of January 1970 or the 1st of January 1900, which is not a real business date, but may be treated as one unless it is explicitly recognized as a sentinel. Numeric fields might arrive as text with spaces, commas, or symbols, and failed conversion can yield nulls or zeros depending on how the pipeline handles errors. Text fields can contain strings like NA, null, or unknown, which are not true nulls but effectively represent missingness and must be normalized deliberately. These hidden forms of missingness are dangerous because they pass superficial checks, and they can distort distributions in ways that are hard to detect without targeted profiling. A repeatable missingness checklist is most useful when it is treated as a habit of observation rather than a one-time project, and it can be described as a sequence of questions that stays consistent across datasets. First, the dataset benefits from clear state definitions, so missing, null, blank, and zero are separated in meaning and in how they are counted. Next, missingness can be summarized overall and then compared across key slices like time, region, and device to reveal clustering that changes interpretation. Then, related fields can be reviewed together to see whether missingness travels in groups, which often points to a single upstream cause, such as a missing identifier or an extraction defect. Finally, any treatments and exclusions can be recorded with rationale, and missingness can be checked again after merges and transformations to confirm the handling still holds. The conclusion of episode 22 is a simple assignment. Pick one dataset and profile it for nulls before any deeper analysis, because the fastest way to internalize this skill is to see it in real data. The dataset can be small or large, but it should have at least a few fields that matter to decisions, because missingness is most revealing when it threatens something important. The goal is not perfection, but clarity, meaning a clear picture of how much is missing, where it clusters, and whether it looks random or systematic in the context of the business process that produced it. Once that profile exists, decisions about imputation, flags, or exclusions stop being guesses and become defensible choices. And that is exactly how analysis avoids going wrong quietly. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.